string.byte. You give it a character as a string, for example A, then it gives you back that character's numerical code, internal numerical code, like how it's actually stored by the computer, because it's stored as a number, pretty much, because computers doesn't know a character or a string or whatever. And a string is basically a series, or what I can say, a list of characters, basically. Anyway, so if I execute this, as you can see, it gave me back 97. That means that A is represented as the number 97 internally. And what I mean by internally, in computers, we represent numbers usually, or at least in the old days, or most of the systems, using Ascii Table, okay, or Ascii code. So this is the Ascii table right now. As you can see, for example, space have a code or a number of 32, 0 have a number of 48, 6 have a number of 54. Let's check. Let's make sure that's the case. For example, let's get 3, the number 3, or the character 3. Let's see if it's actually equal to 51 or not. All right, 3. I'm just gonna, as you can see, it tells me 51. Now let's say I want the, like I have the code of that character, and I wanted the actual character as a string. For example, M. I have 77. I know that the character code is 77. So what I can do, I can use another function called string.char. Instead of giving it a string, what I should do is give it a number. So 77, if I do remember well, and as you can see, it gave me back a uppercase M. But notice that a uppercase M is really different from a lowercase m. You see this? So basically they're represented differently, and that's why a lowercase m in programming is not the same as uppercase m usually. So now I've shown you pretty much how you can use these functions and stuff like that. However, you might ask yourself that this is really useless, and that's why it's so like underrated. So right now I'm going to show you a use case for this, a really useful use case. Let's say I have a function, okay, is number. So this function, you give it a character as a string, right? And this number should tells you if that character is a number character, right? So how we can do this? Well, first of all, I'm going to get the byte of that character, or the numerical code of my char. So I can do that, char code or byte equal to string.byte char, right? Now I got the char byte, basically the numerical code behind my character string. Now I'm going to compare that char byte to something. So return, here I'm going to return the result of the function. Okay, char byte is less than, or actually greater than or equal to string.byte 0. And to make it more clear what I'm doing here, I'm just going to add a constant called 0 byte. I'm going to add this to there. And then local 9 byte equals string.byte 9, the character 9. There we go. So now the char byte, so the byte of my character should be greater than or equal to the 0 byte. And char byte is less than or equal to 9 bytes. All right. And let me add a comment here to clear this up. So basically, 0 byte is less than or equal to char byte, and char byte is less than or equal to 9 bytes. All right, so this should work. If I say print is number, let's say 1, for example. As you can see, it told me true. I gave it a character, which is the character 1, and then it told me true. That number is actually a number character. What about 9? What about 5? What about, yeah, 6, 5, 4, etc. It works. However, you say, for example, A, it told you false, or it tells you false. All right, cool stuff. Now, why this works? So as you can see, I just made a function that tells you if a character is a number character or not. So how this works? Notice that 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is ordered in the Ascii table, right? So as you can see, it starts by 48, it goes on to 49, 50, 51, 52, 53, etc., etc., etc. So I use that to my advantage. First of all, I get the byte, so the numerical code of 0, or the character 0, which is 48. And then I get the numerical code of 9, which is 57. And now I also get the numerical code of my character, then I want to verify if it's a number or not. All right? Then I check if that numerical code of my character is between 0 and 9 or equal to one of them. If that's the case, then that's true. My character is actually a number character, right? Otherwise, it's not, because it's not between or equal to 0 or 9, basically. So that's how it works. And notice one other thing is that also the alphabets are also ordered the same way. So A, B, C, D, E, F, etc. It starts from 65 and it goes on to 90. And also notice that uppercase character doesn't equal to a lowercase character, okay? Now let's make a function. Local function is lowercase letter. And then you give it a char, or actually let's say is lowercase char. Is number char. All right, cool stuff. Now let's do end. All right. So is lowercase char. How we can do this? Well, first of all, we give the char byte equal to string.byte char. Right? Cool. Now what we want to do basically is a byte should be less than or equal to char byte, less than or equal to z byte. So this is what I'm going to do. Basically, I'm going to copy this. And then instead of 0 bytes, I'm going to say a byte. Instead of 9 bytes, I'm going to say z byte. There we go. Now, of course, I need to define those constants. I'm just going to copy this, guys. Instead of 0, I'm going to say az. Just like that. All right, so 0, 9. Actually, let's say is uppercase letter for now. Is uppercase character. There we go. All right, z byte, string.byte, 9. Well, here I'm going to say z and here a. There we go. Cool stuff. Now this should work. Is uppercase char, for example, a. As you can see, it told me true. What about c? What about y? As you can see, it's true. However, if they say something like 1, 2 points, then it says false. Because that character point, its numerical code doesn't lie in the range of the numerical codes of the alphabets. Of course, the uppercase alphabets. Now let's do the same thing with the lowercase ones. So I'm just going to copy these constants again. I'm going to say lowercase and lowercase z. So ZA, there we go. Now I'm gonna copy this function, basically. And I'm gonna say is lowercase char. All right, let's see. Now I just gotta change, I'm just gonna add L and L here. And there we go, boom. Now if I print is lowercase char, well, let's give it a char. For example, A, as you can see, it's a lowercase, so that gives us a true. A, uppercase doesn't work, it's false. A number doesn't work too, which is great. That's what we wanted. Now what about any character? Doesn't matter if it's lowercase or uppercase, any alphabet character. So is, let's say alpha char, is alphabet char. Char, all right. And so what I can do is return is lowercase char or is uppercase char. However, there's also another way of doing it, which is much more better and faster and etc. etc. So here's what I'm going to do. So I'm going to do the same thing as one of these guys. Doesn't matter which one. All right, by the way, I'm going to delete this comment though, because it's just going to, I need to update it every time I copy the function, which is painful. So yeah, I'm going to leave that for that. All right, cool. Now, is alphabet char. Here's what I can do. Char, let's say, for example, upper. Or actually, let's use string.upper like this. So what this function does basically is it gets any string and it returns it as an uppercase string. All right, so I can give it char. And so basically, any character that I get, I convert it into an actual uppercase character. Right? Then I check if that uppercase character is between a byte, which is uppercase A, and uppercase Z. Otherwise, I can do the same thing. If I have like, let's say LA, which is lowercase a byte and lowercase z byte, I can use that. However, I should use string.lowercase or string.lower, just like this. All right, so I guess that's it. Now, basically, if I print is alphabet char, A, for example, as you can see, true, and uppercase A is also true, which is quite nice. Now, let me show you another use case. Let's say I wanted to, like remake string.upper or string.lower, basically. How I can do that? Well, local function, let's say upper char. All right, char, end. So let's see how we can do it. Well, now notice one thing. So here is the uppercase characters, and here's the lowercase characters. Now we need to know the difference between these two. Like how much offset you need to add to convert a lowercase character to uppercase character, etc., etc. So let's see. So for example, let's say I have C uppercase, right? Well, actually what I want to do is upper char. So let's say actually let's just go with, first of all, lower char. Okay. So let's say I have C uppercase and I want to convert it to C lowercase. Well, what I can do is add, and I need to add some number, some offset that will give me the counter, like the lowercase counterpart of that character's number. So for example, C, like uppercase C is 67 and lowercase c is 99. So if I bring up my calculator here and say 99, minus, so basically the number of C lowercase minus 67 equal to. So as you can see, there's a difference of 32. All right, now let's try this out. Let's take, for example, H. It's 72, as you can see. So if I say 72 plus 32, which is the difference that I found before, or the offset that I found, and say equal, it tells me 1/4. And if I looked into 1/4, as you can see, it gave me back the counterpart in lowercase. So that's perfect. So basically, what we need to do is basically say return string.char, because we do want to like change the byte and then cast it back into a normal character. So string.char, string.byte, char. Let me make this clear by making this into a variable, local char byte, equal to string.byte char. Okay. So string.char char byte plus 32. Now this should work perfectly. Well, not really perfect, so you'll see why, but yeah, it's a good step towards our goal. So let's say I have A. All right, so what happened here? Okay, I didn't use the lower char function. So let's use that, and there we go. As you can see, lower char A gives me A lowercase. Uppercase B gives me lowercase b. So as you can see, it works perfectly. However, we have one problem. So it does work when the character needs conversion, which means that we have an uppercase character and we're trying to convert it into an actual lowercase character. However, if you say a lowercase character, so it's already lowercase, for example, A, then as you can see, you get another character. You don't get the same character, which is not good, right? All right, so how we can fix this? Well, so there's two ways of doing this, actually, but I'll explain. So we can check first if our char or our character is in the range, or it's a lowercase character, or it's an uppercase character, etc., etc., okay? So let's do that actually first. So if is lowercase, so I'm going to use my previous function. So is lowercase char, and I'm going to give it my char here, then end. Or I can basically copy this thing and do it like this, and just make sure that I do it after defining the char byte. So if this is true, which means our character is already a lowercase character, then what we're going to do is we should return char itself. Else, we return this thing. So we return its conversion, which works pretty fine. Let me see. A. So as you can see, when it's A, so it's a lowercase character, then it just returns the same character without changing anything. However, if let's say A uppercase instead of lowercase, then it actually converts it. But the thing is, let's say I said 1, then it will actually do the thing. So as you can see, it tells me Q, which is not good. Well, it does depend on your use case, but usually you don't want that to happen. So what I can do actually is check if it's a uppercase character. So it does depend on your use case, doesn't matter. So, but for the usual task, it works no matter what. So yeah, so I can do the opposite. Check if it's actually a uppercase character. If it is, then I'm going to return that thing. Otherwise, I'm going to return the char itself. So basically what I say here, if it's an uppercase character, then convert it. Otherwise, it's return the character without modifying it. So as you can see here, it says 1, 2, B, or let's say A, for example. As you can see, it makes it lowercase. B, it makes it lowercase, etc., etc. And I should note that string.byte, let's say I have a string, ABC, for example, okay? Then I took the byte of it. Let's see A, for example, equal to, or let's say X equal to string.byte, str. Or actually, let's just go ahead and say it directly. Now, the thing is, if you print X, what it's going to give you is the byte of the first character, okay? But it actually does give you the bytes of all the characters inside that string, like this way. So if I say X, Y, Z, hopefully, no, it doesn't. Why? Because I didn't tell it to do so. What about this now? And as you can see, it works. So by default, it only takes the byte of the first character. Otherwise, you can change the where you get the bytes. For example, if you say 2, then it will give you back the byte of B and C, so X and Y. And you can play with it like however you want. But yeah, that's just something to be aware of. Anyway. And actually, let's see how the actual built-in function of upper works. So if I say print string.upper A, for example, uppercase. So as you can see, it works. Lowercase, it works. However, if it's another character, then it just gives you back that character. So that works the exact same as this implementation. So that's perfect. And for the lower, like the upper char function, we can just copy that one and do the opposite. Check if it's a lowercase character. Right? Now the thing is, this is upper char. The thing is, we gotta do the reverse. Because you remember that, let's say I have an uppercase character, for example, C, and I want a lowercase character. Then what I do is basically add 30. So I jump up to 30 characters forward, and then I find my character. However, right now, I want to do the opposite. I have a lowercase character, and I want to go back to an uppercase character. So instead of, like adding 32, I can do minus 32. That's what reverse is. All right? So let's do that. Char byte minus 32. And then if we do this, wait a sec. Now let's try that up. Print upper char. So if we have a uppercase character, then it leaves it as it is. If we have a lowercase character, then it returns it as an uppercase character. Cool. That works perfectly. Now I can also use my own function right here and here. So what I can do is copy these functions. Is lowercase character. Wait, what I'm doing? No, is alphabet character char. I can copy it and put it here. And then instead of string.upper, I can use my own version of it, upper char or upper char. There we go. As you can see, in this whole thing, I only used string.byte, a little bit of math, a little bit of comparison, and that's basically it. And I actually did all of this, and there's a lot of things that you can do with this, not just this. Let me show you another example before closing up. Right? If you want a second part, then let me know. But yeah, let me show you another example. Let's say I have a function called encrypt. I give it a str or string, right? And then it should return to me another string with the same length. But what happens is that I want to shift all the characters by a defined amount of offset. And also before actually, going forward with this, I just wanted to let you know that we can actually, instead of hard coding 32, we can do the same thing here. Local, upper, lower, char offset, for example. My naming is really stupid, but yeah, you get the point. String.byte. You can say, for example, a minus, la byte, because I already have it there, minus a byte. And that should work perfectly. It should give you back that thing. If I print here that, as you can see, print upper lower char offset, it gives me back 32, which is cool. And then I can go ahead and use it in my functions instead of hard coding it. Usually you want to avoid hard coding values that might change in the future or anything in that matters. But yeah. So my encrypt function, it will give me back a string. All right, let's see what we can do with that. Okay. So let's say I have a table. Well, I'm going to use some other features of Lua, or some other standard functions of Lua that I'm going to make a video about later on if you want me to. But for now, just hang with me just so you can see what you can really achieve with this thing. All right, so I'm going to return basically table.concatenate. I'm basically creating a table or list, you know, I call it t, and then at the end I'm returning table.concatenate, which means I'm gonna take all the elements of this table and, you know, like join them together into a string basically. So if I have, for example, hello like this, comma world, then I'm gonna get back this table as a string, hello world, you know, if I say table.concate this table. So that's it. Now here, what I should do. So I'm gonna say for I equal to 1, because the index of a string character begins at 1. And then I'm gonna say this guy right here, this hash, I think, or whichever that is, or hashtag, right? str do end, comma 1. I'm gonna go with one character at a time. All right. So I'm gonna get first my character, which is string.sub. I'm gonna use another function right here, which takes a substring, basically one part of a string. I'm gonna say str, comma I. Basically, I'm taking that character in that specific index. So if for example, I print char here, so you can see what's going on there. Let me run this and say encrypt, for example, hello. As you can see, this is what I got. So I'm getting individual characters, so I can actually work on them, process them one by one. Cool. Now, what I can do, I can get the char byte. So string.byte char. And what I'm gonna do also is like local new char. Let's say encrypted char equal to char byte plus key. Key is just a number. If key is equal to 0, then that means that this string won't be changed. Otherwise, it will shift the character n times depending on the key. So key times, kinds of. Anyway, and then basically what I'm going to say, table.insert. So I'm going to insert an element in the table, which is t, comma. So I'm going to insert into the table t, string.char, encrypted char, and let's not forget this is encrypted char byte. Okay, so I'm gonna convert that byte into an actual character string, and I'm gonna insert it into the table t. And now let's try this up. Of course, there is a problem with this that we're gonna fix, but for now it should be okay. Let's see. For example, encrypt hello, and I gave it a key of 0. Let me print the result. Well, it just gave me back my string, my original string, which is hello. However, if I change the key to something other than 0, let's say, for example, 1, then I get another string. Right here, it's fmmp. So what happened there? Let's see. So hello. Let's say h, for example. H, where's h? There we go. If we added one character, then we get I. Let me see if that's the case. There we go, I. What about E, the character E? So here's the character E. It gives us back. The next character is F. All right, so as you can see, there we go, F. And there's two L's, and what's after L is M. So as you can see, there is, well, two M's. And for O, let's see, there we go, O. After it, there is P. And that's why we get FMMP. All right, I think you get this where it's going. If I say 2, then instead of adding one character, I'm going to add 2 characters. There we go. H-I-G. That's why there's G right there. 3, 4, lips, whore. Okay, that is crazy. 5. But there is a really big, like at least the real deal right here is that the problem with this encrypting algorithm is that you do know which characters does actually repeat. For example, right here, you know that whatever character that is behind Q, it's getting repeated 2 times. So you can actually see a pattern and somehow decrypt it without even knowing the key. So that's just, one obvious problem with this encryption method. However, you shouldn't use it at all unless, for fun, or you just, I don't know, like I don't really have a real world use case for this for now. Maybe like jumbled upwards for your user or something, I don't know, but yeah, whatever. But the problem with this is that if I say, for example, 100, then I get some gibberish. Why? Because basically what happens is that, let's say, for example, Z. Let's just say 1. So as you can see, Z gives us this thing right here, because after Z, there's this character. But we might not want that thing to happen. What we want basically is, when Z is a thing, then we want to go back into A, for example, or something like this. Or something like that, basically. So yeah, let's say I want only the numbers, or only the characters from, let's say from, well, let's say I only want the characters from space to this character right here, because they're the ones who looks valid, basically. So how we can actually do that? So for example, if it's Z, or actually if it's this character, then it goes back into space, and it goes up like this, like this, like this, and it goes back to space again, and like that. So how we can do this? Well, let's see. All right, char by plus key. So there we go. This is the problem. So I'm going to show you another function that I'm going to explain later on, but there we go. Local function. I'm going to call it warp. You're going to give it a value, a minimum and a maximum. Or actually, let's start by min and max, then value. All right, end. So this will return, well, I believe, x. Well, let me look up one thing. All right, so I made this function before myself. Right now, I'm just going to paste it from my old project. There we go. All right, so this function right here, it's using the modulo. I can explain for you the modulo later on in another video, but yeah. So basically what I'm going to do is warp this value, which is char byte plus key, comma, and I'm going to say the minimum, which is string.byte, right? String.byte, space, string.byte. The last character I want is this. And let's go. Well, not that one, this one, right, there we go. Because it looks for me that the first valid character, those are called like the control characters. So the first valid, like actual character is space, and then the last one is this tilde. So that's why I'm going to use them as the start and the last. All right, so let's do that. So this warp function, when, like, let's say you go beyond or you overflow over the tilde numerical code, then you're going to go back to space, and you're going to go like that, basically. Now let's see what's happening here. So let's say, for example, tilde. So it's giving me space, however, I don't see it. So let's actually delete space for now. Let's start by the exclamation mark. And as you can see right now, since we're at the end of the warp range, which is the tilde, it gives me back the first character because we're warping. So that's what this function does. I'm going to explain how it works later on in another video. But yeah, now I can go wild. So right now there is no problem using this function, hello world, and I can choose whatever key I want, and it will work just fine as long as the key is not overflowing real blocks or actually Lewis numbers. So as you can see, this is perfect though, really perfect. I like this. There we go. It works perfectly. So you can choose whatever keys. Obviously, there is limited amount of actual unique keys because of the warp function, since we only have limited characters that we can map to. So of course we have limited unique keys. However, you can choose whatever key you want. It's just like a cyclic kinds of key. But yeah, so as you can see, there's a lot of problems with this function, as if you want to use it for security, like to actually encrypt actual data. Since, like, you can notice the patterns. So for example, hello, in hello, you can see that it gets like repeated 2 times. So you might notice the pattern, and also space will be really frequent between like words. So you can see, for example, here, this thing, well, do you see that? There we go. And also the key is cyclic, and if you just do a bit of calculations, you can figure out the key. But yeah. So that was it for this video. It was a really long video, however, I really gave you a lot of information. Feel free to use any of this. Credits are appreciated, but not necessarily. Like, not really required. But yeah, anyway, see you later, guys. Goodbye.